All right, last video for the day. A little bit of more practice for you guys. So on this page, I'll be doing problems 2 with you. We'll do 4 and we will do 7 together. So in this area, remember, the rule is they want anything that's perfect not to be underneath or inside the radicals. So before we start, just a little reminder that we talked about and we wrote in our notes that if we take the cubed root of -1, that's just -1. And so the first thing I'm going to do to make this a little bit easier is I'm going to make a factor tree for 64. And I'm going to do this over on the left side. You can do this on another different piece of paper. So it's actually -64, so I'm going to break this into -1 and 64. And as you can see, I'm just going to walk through this super fast. All right, so now if I just focus on what's left, I have 1, 2, 3, 4, 5, 6 2's and a -1. So I'm going to rewrite this as -1, 2 to the 6th, M5, P8, Q5. So from there we talked about we're going to make our perfect set and our not perfect set. And the perfect is going first, so -1, it will be perfect. All of the 2's can go in there. Of my 5 M's, 3 can go in and 2 don't. Of my 8 P's, 6 can go in, but 2 cannot. And of my 5 Q's, 3 can go in and 2 cannot. So now I'm going to take everything out. So the cubed root of -1 is -1. 2 comes out, it gets an exponent of 3. M comes out, P gets an exponent of 2, and Q come out. And those both have, the M and Q have an exponent of 1. And the not perfect stuff can stay in there. And it would be really great if you would clean up this left part right here. So I'm going to do that. 2 cubed is 8, and 8 times -1 is -8. So here is the final answer. All right, moving on to problem 4. So quick factor tree of 192. We'll start out with 2 and 96. This can break into 48 and 2, 6 and 8, 2 and 3, 4 and 2, as you can see. So when I'm done, I'm going to rewrite 192 as a total of 1, 2, 3, 4, 5, 6 2's and a 3. 3 the first. And then I still have my A's and B's and C's in there. And now I'll make my perfect and my not perfect. So all of the 2's can go in there. 3 to the first cannot. A cubed, all of that can go in there. B doesn't have enough. And of my 4 C's, 3 can go in, but 1 can't. So now I'll take everything out. 2 gets an exponent of 2, A and C. And then it would be great if you could take that one step further, make 2 squared into 4. All right, there is number 4. And moving on, number 7. So number 7, you can make a factor tree as well. I'll do that over here. And the more you make the factor trees, you'll start to just see the numbers, and maybe you don't have to make the full factor tree. But when I'm done, I have a total of 1, 2, 3, 4, 5 2's. So I'll rewrite this as 2 to the 5th. Now I'm going to make my perfect and my not perfect. And of those 2's, 4 are perfect, 1 isn't. Of my H's, 4 are perfect and 3 aren't. And of my J's, 4 are perfect and 2 aren't. And then the K is not perfect. So coming out will be 2, H, and J. They all have an exponent of 1, which I'm not going to write. And of my 4th power, I have this. Whoops, there's my squared. And number 7 is done. So maybe pause here so you can work on the rest of this page, but I'm going to go ahead and do a few examples here on the other one. And I know this is a lot to do, so you guys can handle this. So let's see, I'm going to pick problems I'm going to pick problems 2, 6, and 7. So a good idea to have in front of you, again, are your notes from page 8. The first rule says just to simplify. So since it's a fraction, I will be dividing, and I'm just going to simplify the fraction 4/18 and not have as many r's. So when I do that, just a second, 4/18, I can divide 4 and 18 both by 2 and get 2 9ths. And as far as my r goes, I can just bring that down to r to the 4th in the bottom. The next thing I want to do is rule number 2, which says no fraction under the radical. Well, that rule's already been taken care of. They've broken it up so that there's a radical on the top, a radical in the denominator, but there's not a fraction under the radical. So this next step is I'm going to make a factor tree for any number that I can make a factor tree for. So 2 I can't make a factor tree for, but 9 I can make into a factor tree. So I'm going to just move down here. And that's a pretty simple factor tree. That just becomes 3 squared. And now I'm going to move into step 4. This is the tough step. This step says you cannot have a check mark or radical in the denominator. So what I'm going to do is fix the denominator so it's perfect, and that way anything perfect can come out, and then I won't have a check mark in the denominator. So I will do that by multiplying by another cubed root, because cube roots only multiply with cube roots. You have to have the same or common index. So of my 2 3's, if I just give it 1 more, I'll have enough 3's to be perfect. And for my 4 r's, if I give it 2 more, I'll have enough r's so that it's perfect. And again, whatever you do to the bottom, you do to the top, because this fraction that's showing up in red is really just worth 1. Anything divided by itself is worth 1. So continuing on to step 4, the second part, for b, now I just want to simplify. So I want to multiply and combine the numerators and the denominators. So I always start with the denominators. I like to get that perfect stuff done. So now I have a total of 3 3's and 6 r's. And now that denominator is perfect, and I'm going to jump to rule number 5 for the denominator and take all the perfect stuff out. So 3 can come out and r can come out, but it has an exponent of 2. And now I'll simplify my numerator. So I'm just going to put these two together since they're both cube roots. So just carrying over here. So I'm going to have 2 times 3 times r squared. And none of those are perfect. They don't have enough 2's or 3's or any more r's up there. So they'll just stay in there. But I will take the 2 and the 3 that's in the check mark and just make it 6. And this is done. You cannot take the r squared in top and cancel out the r squared in bottom, because it's not r squared on top. It's actually inside a cube root, so it's not worth the same amount. All right, next problem I'm going to do for you. Let's see, number 6. Let's do number 6 together. So the first thing I'm going to do is go ahead and divide. I'm going to simplify that fraction. So as far as the numbers go, 6 and 24, I can divide both of those by 6 and get 1 and 4. My u's I can simplify, so I just have 1 u in the bottom, and my v's I can simplify, so I just have 2 in the top. Step 2 says no fraction under the radical. That doesn't happen. It's already been broken up. So I'm going to go to step 3 and make a factor tree. So the only one I'm going to make a factor tree for is the 4. And if I do that, 4 as a factor tree is just 2 squared. And I'm just rewriting the numerator, but instead of 1 and b squared, I'm just going to make it b squared. All right, so now I'm going to deal with step 4, the tough step. No radicals under the denominator. So first I'm going to fix the denominator. So to do that, I'm going to multiply it by another 4th root, and I need more 2's and more u's. So with my 2 2's that I have, if I give 2 more, now it's perfect, and the 1 u needs 3 more. And again, whatever you do to the bottom, you do to the top. And now I'm going to go to step 4b and 5 kind of all together. I'm first going to multiply my denominators, combine them up. So I'm going to the 4th root. I now have 4 2's and I have 4 u's, and I'll go ahead and get that stuff and take out the perfect stuff. So the 2's can come out and the u can come out. Now my numerator. So my numerator, I'm just going to combine these two since they're both 4th roots. put them under 1 fourth root instead of 2. So I'll have 2 squared, u squared, v squared. None of that is perfect, so I'm just going to bring it along. But I will turn 2 squared into 4, and I'm going to have u squared, v squared. And now this problem is done. And one more. The next problem I'm going to do with you is problem 7. So same first step. I'm just going to simplify with, as far as the numbers go, there's not 4 there. 4 and 18. I'm going to take a 2 out of both of those and make it 2 and 9. And then my v's, I'm going to make it into v squared. And then I'm going to make a factor tree. I can't make a factor tree for 2. Nothing happens there, but I can make a factor tree for 9 and turn it into 3 squared. So that's what I'm going to do here. All right, so at this point, when I look, dealing with step 4, no radicals in the denominator. Well, if you guys look, the denominator, because there are little 2's here that we're not seeing, the denominator's perfect actually. I don't have to fix it. I can just go straight to rule number 5 and take all that perfect stuff out. So 3 squared can become 3, v squared can become v. That 2 to the first power, that cannot come out, so it's just going to be the square root of 2 on top. And then you are done with number 7. And that's it. So you should have, at this point, your pink page done. You should have your practice mile marker done. That was gold. And then working on this page. And whatever you don't finish, that is your homework.